Welcome to Flipped Classroom. We are looking at measurement, and today's lesson is on the area of squares, rectangles, and triangles. Our learning intention is we are learning to calculate the area of squares, rectangles, and triangles, and I'm successful when I can identify the correct formula to calculate the areas of different shapes, use a formula to calculate area, and identify the correct unit of measurement for each shape. Thinking back to what we know about perimeter and area, what is the difference between the two? So perimeter is the distance around the outside of the shape, whereas area is the space inside the shape. Here we have the rules for some basic shapes. So let's start off with a square. Now, if we know the length of one side of a square, we know the length of all the sides. And the formula for an area of a square is length times length, or length squared. So if I have a question, what is the area of a square of length 4 centimeters? I just get the length that I know, 4 centimeters, and I square it. So I have 4 times 4, which is 16, and the units are centimeters squared because we started off with units of centimeters, and area units are always squared units. For a rectangle, it's similar to a square. We need the length and the width. So the formula is area equals length times width. And my example is what is the area of a rectangle with length 7 meters and width 5 meters. So again, I just put it into the formula. Area equals 7 times 5, which equals 35 meters squared because both of our units were meters. Now for the last one, it is a triangle. And it's similar to a rectangle, but there is a little bit of a twist here. So with the triangle, we've got base times height, and then we divide by 2. So my example here is what is the area of a triangle with base 8 and height 4 meters? So I do 8 times 4 divided by 2, which equals 16 meters squared. The next question we have is why are triangles' areas halved? So here I have 2 rectangles, but this time, instead of making them length by width, I'm going to call them base by height so that it's the same as a triangle. If I worked out the area of those rectangles, it would just be base times height. Now for the first rectangle, I'm going to cut it into 2 and I'm slicing it from corner to corner. So I have a blue triangle and a red triangle. It's easy to see that both the blue and the red triangle are congruent or identical. And because they're identical, that means they are half of the original rectangle. And that gives us a reason as to why that's half. But let's see if that's the same with a triangle that's not just from corner to corner of that rectangle. So here I'll draw another triangle. And I've just picked a random spot along the top. Now we've got the base and we've got the height, and we've got to remember that those things have to be at 90 degrees to each other. So I have this other triangle over here and a second triangle there. So if I get those 2 triangles and I bring them down, I have them down here. And now I'll rearrange them a little bit so that they are back to back. And we can see that that yellow-green triangle is the same as the blue triangle. So that's showing that it is half the area of the whole rectangle. So why does knowing the rectangle's formula help us with a square and a triangle's formula? Go back and have a look at those rules, and that might help you out with this bit of reflection. As always, like the video and subscribe for more on maths.